Okay, now we're finally going to start the simplex method. These are problems, they're maximization problems, and all the constraints have the form less than or equal to. So this is how one is normally set up. You're given your objective function subject to these constraints. And these are my non-negative constraints. Remember, my variables have got to all be greater than or equal to 0. So the initial simplex tableau, we've had this earlier. We're going to introduce slack variables into the problem constraints and rewrite the objective function with all variables to the left of the equal sign. Once completed, make a matrix in the following form. So remember, I've got two solid lines inside the matrix. One's vertical that separates all the variables from the constants, and one is horizontal that separates the linear constraints from the objective function. Now remember, in the simplex method, the constraints and the objective function are together in the matrix. It's called my initial tableau. So what I need you to do is go ahead with this original problem and get it ready. Add your slack variables and then put it into the matrix. I need you to pause me because this is something that you've got to be able to do. So I'm going to add my S sub 1 and S sub 2 here. So I'm going to have 3x sub 1 plus 8x sub 2 plus S sub 1 is equal to 24. X sub 1 plus 4x sub 2 plus S sub 2 equal 12. See what I've got so far. So that would be the 3, 8. Remember, I've got my S sub 1 in the first one. And you've got to actually have these column headings because it'll keep everybody straight that way. And here's my equal sign. Be careful on the next part. This is where some people slip up. My objective function goes in the bottom row, but on the right hand side has to be 0. So all these terms have got to move to the left, and when you move terms, you change signs. So I'm going to have a negative 5x sub 1 minus 7x sub 2. So I should have a negative 5, negative 7, 0, 0, 1, 0. And let's see if I do. And there we are. So that's my initial simplex tableau for the prior problem. So in the following, the thing that you've got to understand here, and I mentioned it back when we were doing the Gauss-Jordan, we're going to do something similar to the Gauss-Jordan, but I cannot use the RREF key. Not going to work. We're going to have to find what's called a pivot. And let's see if you remember, or this sounds familiar. It says pivot once is indicated in the following simplex tableau, and read the solution from the result. My pivot, this thing that my circle is around, I've got to make it a 1. Everything else in the column I have to make 0. So that sort of sounds like my Gauss-Jordan. It's a little bit different because I don't have to have a 1 here and then 0. My 1 can be anywhere, but once I find my pivot, I make the pivot position a 1, and I use it to make everything else in the column 0. So the first thing I'm going to do is make this position a 1, so I'm going to multiply row 2 by 1/2. Always got to do that first. Now I'm going to use it to get rid of the following. I'm going to make this position a 0. So the opposite is a negative 1. So I'm going to do negative 1 times row 2, add to row 1 to give me my new row 1. I've got to make this position a 0. So I'm going to have a negative 3 times row 2, add to row 3 to give me my new row 3. And all the way, the whole column, I'm going to make this position a 0, and I'm going to multiply row 2 by a positive 2. So 2 times row 2, add to row 4 to give me my new row 4. So this should look familiar. The only difference is it's similar to the Gauss-Jordan. I actually call this a Gauss-Jordan column I'm working on, but like I said, it can occur anywhere. So I need you to put this into your calculator and see if you remember how to input these steps. So I think I've already got my matrix in. Okay. So first step, second matrix over. I need to go up and up one more because all I'm doing is multiplying. So 1/2. I have to tell it the matrix And now I have to tell it the row. And notice here's my 1 right here. Always remember, check to see if what you wanted to accomplish you did. Remember, I also have to store this thing every time I do one of these steps. Okay. Now, I'm ready for this part. Second matrix over, up. So -1, comma, tell it the matrix, comma, 2, comma, 1. And there's my 0. So store second matrix. Okay. So I've got to do that same step again. So let me do second enter, and I'm going to go back in and modify. I need a 3 here. Everything else is the same. I'm going to put a 3 here. And that should take care of that one. Yep. So store second matrix. And let's take care of that. So second enter. I need a +2. Multiply the matrix, the second row, add to the 4th. Went too far. Add to the 4th. Store second matrix. Okay. So these are nice, or you could put it in fractional form. And see if mine corresponds. -½ 1.5, -7/2. There's my halves. Okay. Now, to read this matrix, you've got to know the difference between a Gauss-Jordan column and a non-Gauss-Jordan column. The Gauss-Jordan column are the ones that are going to actually take up values that are on the other side of the equal sign. If it's not a Gauss-Jordan column, that's my non-basic, it's going to be 0. So x1 is not a Gauss-Jordan column, so it's going to be 0. x2 is going to be 0. x3, if you'll notice, it's a Gauss-Jordan column. Follow the 1 across the equal sign, so x3 is going to be 50. s1, Gauss-Jordan column, followed across, it equals 10. s2, not a Gauss-Jordan column, s2 is going to be 0. s3 is a Gauss-Jordan column. See where the 1 is? Follow it straight. s3 is equal to 50. P is a Gauss-Jordan column. P is equal to 100. So let's see if that's what I've got right here. So x1 is 0, x2 is 0, x3 is 50, s1 is 10, s2 is 0, s3 is 50. Maximum value, P is equal to 100. And this is how we have to go about reading them. Every time we do a matrix, we need to read the solution, because guys, all of these values in here they have to be greater than or equal to 0. And that tells me that I have done the problem correctly. So that's it for this video. Thank you.